You're looking at an example of Cisco's proprietary first hop redundancy protocol, HSRP, Hot Standby Router Protocol. And with HSRP, you will have routers in a group. Now, when I say router, we're also talking about multi-layer switches here. But you're going to have multiple routers in a group, an HSRP group. And these routers share something in common. They share an interface that is part of the exact same local area network, the exact same subnet. So in this case, we're looking at the 10.1.10.0/24 network as an example. And the IP address of this interface is 10.1.10.2, and the IP address of this interface is 10.1.10.3. You can only have one forwarding router and one standby router for HSRP. So the forwarding router will be the one that's forwarding traffic at that point in time. The standby router is the router that's waiting for the forwarding router to fail so it can take over the forwarding process. However, you have other routers in the group. And the other routers that are in the group are going to be simply waiting for one of these routers to fail so they can come in and replace them. So if you have 4 or 5 or 6 routers that could be a default gateway for that same subnet, then you could add them all into the group. But remember, only one forwarding router and only one standby router at any given time, and then all the other routers are just waiting for a failure to occur so they can take over. So with HSRP, we configure the routers in the group and we supply them with a virtual IP address. So this virtual IP address is going to be the IP address that is given out to all of our clients. So in this case, that virtual IP address is 10.1.10.1. And all the clients are going to be configured with the default gateway of 10.1.10.1. And automatically, a MAC address is going to be created to go along with that particular IP address. So when the client says, hey, what's the MAC address of 10.1.10.1? That MAC address can be given out. And who gives out that MAC address? It's the current forwarding router that's responsible for it. So that forwarding router gives out that particular MAC address. So how do we configure all of this? Well, it's relatively simple. What you will do is you will create what is known as a standby group. Anytime we talk about HSRP, we mention anything HSRP related, it's called a standby group. Everything's standby, 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 as you will see. So none of the commands start off with HSRP. They all start with standby. So the standby group is going to contain all of those routers that are emulating that one specific virtual router. In this case, we're using multi-layer switches. We have DSW1 in this example, and we are using interface VLAN 10 because that's an SVI on our multi-layer switch. And that SVI is going to be the IP address typically that is used as the default gateway for the clients. But since we want to implement now this router redundancy for the default gateways, we are going to have to create that virtual IP address. And that's what's happening down here with the standby command. Standby the group number, in this case it's group 10. Now, is that because it's VLAN 10? No, not at all. But it's recommended that if you are creating a standby group for a particular VLAN, then you might as well make sure that the numbers are the same just for sanity purposes, just to keep yourself straight. The router doesn't care about it at all. Not at all. But for you, it might help ease your pain as an administrator. So standby group 10, IP, and there's the virtual IP address, 10.1.10.1. That's the IP address we're going to configure on our clients. And then on DSW2, we are going to do the exact same thing, standby 10 IP 10.1.10.1. And what this does is it puts those two default gateways in the exact same standby group, which is group 10, and configures with them with the exact same virtual router IP address. Notice that their physical addresses are different on their interfaces. For interface VLAN 10, 10.1.10.2, 10.1.10.3, that's perfect. They're part of the same subnet. And it's out of those interfaces that hello packet's going to go back and forth. And that hello packet is going to be describing the fact that they are members of the HSRP group 10, and the virtual IP address they're using is 10.1.10.1. When we enable HSRP, ICMP redirects are automatically shut off. Now, why is that? Well, ICMP redirects are utilized by routers to inform clients of a better path to use if the path they sent their packet on is suboptimal. So, for example, if the client was sending its packet this way, an ICMP redirect might say, oh, wait, no, you went to the wrong device. You want to go this way. And we don't want that to happen at all, especially if we have a failure. For example, if the router fails or the link fails or something occurs, we don't want this type of traffic flow to occur in our environment. We either want the traffic to flow this way under normal conditions, as an example, and then if and only if that path fails, traffic goes this way. We never want traffic to accidentally do this in our environment or this in our environment. So it disables ICMP redirects to prevent any suboptimal traffic flow within the environment.